Stephen William Hawking entered the world on January 8, 1942, in Oxford, England, a date precisely 300 years after the passing of Galileo Galilei. Hawking took great delight in pointing out this cosmic coincidence, especially when anyone dared to compare his own intellectual journey to that of the legendary Italian astronomer. In the Hawking household, the pursuit of knowledge reigned supreme, far surpassing the allure of mere wealth. His father, Frank Hawking, dedicated his life to the study of parasites, while his mother, Isabel, contributed her skills to a medical research institute. Though not living in opulence, they cultivated a home brimming with books, stimulating debates, and an insatiable curiosity about the world. As a boy, Stephen wasn't the model student topping his class. Yet, he possessed an extraordinary fascination for understanding the inner workings of things. He would eagerly dismantle clocks, radios, and any mechanical device he could lay his hands on, often with less success in putting them back together. His teachers observed that while he wasn't always punctual with assignments, he had a rare and remarkable capacity for abstract thought. His classmates, recognizing his burgeoning brilliance, playfully nicknamed him Einstein, a title that at the time somewhat embarrassed the young Hawking. In 1959, at the age of 17, he embarked on his academic journey at the University of Oxford, choosing to study physics. Stephen wasn't a textbook-glued, traditionally diligent student. He found greater satisfaction in reasoning and critical thinking than in rote memorization. He actively participated in social clubs and even took to the rowing team, opting for a well-rounded experience rather than endless hours sequestered in the library. Yet, his intuitive understanding of mathematical physics allowed him to effortlessly excel. During his final oral examination, the professors quickly realized they were in the presence of a mind operating at a remarkably elevated level. He graduated with honors and earned acceptance into the University of Cambridge to pursue a PhD in cosmology, the study of the universe's origins and evolution. But destiny had an unexpected detour in store. Late in 1962, Stephen began experiencing a growing clumsiness and a series of inexplicable falls. After undergoing extensive medical testing, he received a devastating diagnosis, amyotrophic lateral sclerosis, ALS, the relentless degenerative motor neuron disease. Doctors delivered the grim prognosis. He might only have 2 years left to live. The news struck the young Cambridge scholar like a thunderbolt. Hawking plunged into a deep depression, feeling as though his life had been cut short before it had even had a chance to truly begin. However, two powerful forces helped him fight back against the encroaching darkness: his unwavering passion for understanding the universe's mysteries, and the blossoming relationship with Jane Wilde, who would later become his wife. Jane served as a constant reminder that as long as he was alive, he still had a purpose, and that surrender was simply not an option. With renewed determination, Hawking redirected his energy towards tackling the big questions. He encountered physicist Roger Penrose, whose groundbreaking work on black hole singularities inspired Hawking to apply similar mathematical reasoning to the entire universe. If black holes collapsed into singularities, point of infinite density, Hawking wondered, could the universe itself have originated from such a singularity? This question forever altered the course of his life. Despite his weakening muscles, his mind grew ever sharper. He rigorously constructed mathematical proofs demonstrating that, according to the principles of general relativity, the universe must have indeed originated from a singularity. This groundbreaking result significantly strengthened the scientific foundation of the Big Bang Theory, the prevailing model for the universe's birth. By the late 1960s, Hawking had become recognized as one of the most brilliant young cosmologists at Cambridge. He married Jane in 1965 and continued his PhD research under the guidance of Dennis Iama, a mentor who encouraged bold, unconventional thinking. Soon, Hawking found himself grappling with a profound puzzle. If black holes trapped everything, including light, what happened to the information that fell in? And were black holes truly and completely black? The answers he was about to uncover would shake the very foundations of physics, a journey that unfolds in the coming section. After Hawking's groundbreaking proof that the universe began with singularity, his reputation soared. Yet, it was his daring work on black holes that would truly revolutionize physics. Simultaneously, ALS relentlessly progressed, forcing and confronting increasing physical decline even as his intellect grew sharper and more fearless. Walking with the aid of crutches and speaking with increasing difficulty, Hawking continued to lecture and engage in debates at Cambridge. Colleagues often recalled the sheer intensity of his presence, the soft yet razor-sharp voice, the penetrating questions, the unparalleled ability to identify flaws in a mathematical argument faster than almost anyone else. As his muscles weakened, his mind seemed to expand, as if liberated from physical constraints. It was during this period that Hawking posed a question that no one else dared to consider. Could a black hole emit something? In the realm of classical physics, a black hole was considered a perfect trap. Nothing, not even light, could escape its gravitational clutches. But Hawking applied the principles of quantum mechanics to the edge of a black hole, the event horizon, and studied the behavior of virtual particles, ephemeral fluctuations that constantly flicker in and out of existence in empty space. His insight was revolutionary. If a pair of virtual particles appeared at the event horizon, and one particle fell inward while the other escaped, the escaping particle would manifest as real radiation. In 1974, Hawking published his groundbreaking conclusion: black holes are not completely black. They emit radiation. This radiation, later dubbed Hawking radiation, implied that black holes gradually lose energy and eventually evaporate over immense timescales. The idea sent shock waves through the scientific community. Some physicists initially dismissed it, but Hawking's meticulously derived equations were simply airtight. The discovery forged a profound connection between quantum mechanics, thermodynamics, and general relativity, three pillars of physics that had previously seemed largely disconnected. The announcement propelled Hawking to international fame. At the young age of 32, he was elected as a Fellow of the Royal Society, one of the highest honors in the scientific world. Soon after, he ascended through the academic ranks at Cambridge, ultimately becoming a Lucasian Professor of Mathematics, a prestigious chair once held by none other than Isaac Newton. Yet, behind the accolades lay a growing physical struggle. Hawking increasingly relied on a wheelchair and required assistance with his daily activities. His wife, Jane, tirelessly cared for him while also raising their children. Despite the immense burden, Hawking maintained an unwavering commitment to scientific discovery. He pushed forward with research into the early universe, the enigmatic nature of singularities, and the fundamental geometry of time. One of his key ideas was a no-boundary proposal, a revolutionary model suggesting that time might be curved like the surface of a sphere, with no absolute beginning or end. During this period, Hawking also began making more frequent public appearances. He firmly believed that science should be accessible to everyone, not just scholars sequestered in ivory towers. Knowledge is not frightening, he once said. It only seems frightening when people think they cannot understand it. By the early 1980s, he had become a global icon, a symbol of intellectual brilliance and unwavering resilience. And then, he embarked on a mission to write a book intended to bring the mysteries of the cosmos to the general public. A Brief History of Time. The remarkable story of how that book came to be written, and how it went on to conquer the world, will unfold in the next section. Continuing from the early 1980s, Stephen Hawking initiated what will become one of the most influential publishing ventures in history, A Brief History of Time. What started as a simple ambition to explain the universe to the average person evolved into a monumental work that captivated millions of readers worldwide. Hawking aimed to answer humanity's most fundamental questions in language that everyone could understand. How did the universe come into existence? Does time have a definite beginning or an inevitable end? Are there inherent limits to what we can comprehend? Could physics ultimately produce a unified theory capable of explaining everything? But translating complex concepts like singularities, quantum cosmology, and the very fabric of space-time into everyday language proved to be an arduous task. Hawking meticulously rewrote chapters countless times, painstakingly removing unnecessary mathematical details, and refining his metaphors to ensure that readers without scientific backgrounds could easily follow the narrative. He famously quipped to his editor, "Every equation in the book will cut the readership in half." As a result, he made the conscious decision to include only one formula, E equals mc squared, Einstein's iconic equation relating energy and mass. While diligently working on the book, Hawking's ALS progressed relentlessly. His speech became increasingly difficult to understand. In 1985, he suffered a life-threatening bout of pneumonia, and doctors were forced to perform a tracheotomy, a surgical procedure that saved his life but permanently robbed him of his ability to speak. Many feared that this would mark the definitive end of his career. Instead, it heralded the beginning of a remarkable new chapter. Hawking received a computer-based speech synthesizer that allowed him to choose words and construct sentences electronically. Later, as his mobility further deteriorated, he learned to control the software using a single cheek muscle. His robotic voice, calm, distinct, and strangely expressive, became one of the most recognizable voices in the world, instantly associated with brilliance and perseverance. Despite facing enormous physical obstacles, Hawking remained steadfastly committed to his writing. His enforced silence seemed to sharpen his focus, allowing him to refine every idea, every sentence, with the unwavering determination to make the universe accessible to all. When A Brief History of Time was finally published in 1988, it became an instant phenomenon. It remained on the Sunday Times bestseller list for an unprecedented 237 consecutive weeks, breaking all previous records. It was translated into over 40 languages and sold tens of millions of copies worldwide. More significantly, it transformed Hawking into a global cultural icon, an emblem of intellectual prowess and unyielding spirit. Readers were inspired not only by the profound science contained within its pages, but also by the remarkable life of the man behind it, a mind fearlessly exploring the universe while his body gradually succumbed to the ravages of disease. Hawking encouraged readers to ponder profound philosophical questions. Why does the universe exist at all? What is our place within its vast expanse? But fame also brought its own set of challenges. Hawking was invited to speak at conferences around the world, appeared in numerous documentaries, and became a media sensation. Meanwhile, his personal life faced increasing strain. His wife, Jane, shouldered the immense responsibilities of caregiving and raising their 3 children. The relentless pressure gradually created an emotional distance between them. Still, Hawking remained relentlessly focused on his research. Throughout the 1990s, he worked intensely on the black hole information paradox, a fundamental conflict between quantum mechanics, which asserts that information cannot be destroyed, and general relativity, which implies that information falling into an evaporating black hole might vanish forever from the universe. Hawking initially argued that information could indeed be lost, a bold and controversial claim that ignited a decades-long debate among the world's leading physicists. What ultimately mattered most was not whether Hawking was ultimately proven right or wrong, but that he had once again propelled the scientific community into grappling with its deepest and most fundamental contradictions. In the next section, we will follow Hawking through the later stages of his illustrious career, his ongoing engagement with the information paradox, the significant turning points in his personal life, and his ascension to the status of a global icon of science. Continuing into the 1990s and early 2000s, Stephen Hawking had solidified his position as one of the most recognizable figures in global science. Yet behind the fame and public recognition lay profound personal changes and some of the most intellectually demanding battles of his career, particularly his persistent wrestling with the black hole information paradox. On the personal front, Hawking's long and enduring marriage to Jane eventually came to an end. After years of navigating immense physical challenges and weathering emotional strain, they made the difficult decision to separate and ultimately divorced in 1995. Though undoubtedly painful, the decision brought a sense of relief and renewed purpose to both of them. Despite their separation, they maintained a deep sense of mutual respect and admiration for each other's contributions. Shortly afterward, Hawking married Elaine Mason, one of his dedicated nurses. The marriage proved controversial, with widespread rumors circulating that Elaine was overly strict and even verbally abusive towards him. Friends and colleagues grew increasingly concerned for his well-being, but Hawking, fiercely independent and protective, publicly defended her against the accusations. The marriage eventually ended quietly in 2006, after which Hawking reconnected more closely with his family. Meanwhile, his scientific battles continued with unyielding intensity. For decades, Hawking staunchly defended his controversial claim that information falling into a black hole is irretrievably lost forever, a position that directly contradicted the fundamental principles of quantum mechanics. Opposing him were some of the greatest minds in physics, including Leonard Susskind and Gerard T. Hooft, who passionately argued that information must be conserved. Their disagreement became legendary within the physics community, the famous Black Hole War. The heated debate played a crucial role in advancing groundbreaking theories, such as a holographic principle, which would later become a cornerstone of modern theoretical physics. Then, in 2004, Hawking stunned the world by publicly admitting that he had changed his mind. Black holes, he conceded, do not ultimately destroy information. Instead, information might somehow escape in a highly altered and coded form through a mysterious process of Hawking radiation. He even jokingly acknowledged that he owed a long-standing bet to physicist John Preskill, presenting him with an encyclopedia as a symbolic gesture, a less flashy version of the lost information. Hawking quipped humorously. What truly impressed the scientific community and the wider world was not that Hawking had been proven wrong, but that he so powerfully exemplified the true spirit of science, the intellectual courage to revise one's deeply held beliefs when confronted with compelling new evidence. Moving through the 2000s, Hawking significantly expanded his efforts in public science education. He published several follow-up books designed to make complex scientific concepts accessible to a broader audience, including the universe in a nutshell, A Briefer History of Time, and a series of engaging children's science books co-written with his daughter Lucy Hawking. These works skillfully employed humor, vivid illustrations, and compelling storytelling to explain the wonders of cosmology to young readers. Hawking also continued to cultivate his status as a global cultural icon. He made memorable appearances in popular TV shows such as Star Trek, The Next Generation, The Simpsons, and The Big Bang Theory. These appearances were not merely for entertainment value. They serve as a powerful symbol, demonstrating that science could be fun, engaging, accessible, and seamlessly integrated into everyday life. His unique robotic voice became instantly recognizable, an enduring symbol of intellect, resilience, and the boundless potential of the human mind. Physically, Hawking grew increasingly weak. He gradually lost almost all motor function and required round-the-clock nursing care. Yet his unwavering determination only intensified. He continued to relentlessly pursue the ultimate scientific question. Could humanity ultimately discover a unified theory of everything, a single framework capable of explaining all the fundamental forces and particles in the universe? He collaborated with leading physicists on cutting-edge topics such as string theory, quantum gravity, and the intricate interplay between space-time and subatomic particles. In numerous interviews, Hawking expressed deep optimism about future generations, stating, "We have achieved so much, but I believe future generations will achieve even more. I want to be part of the beginning of that journey." Beyond the realm of physics, Hawking frequently voices informed opinions on pressing global issues, artificial intelligence, climate change, the possibility of extraterrestrial life, and the critical importance of space exploration. He passionately believed that humanity must eventually become a multi-planet species to ensure its long-term survival. Stephen Hawking was no longer simply a scientist. He had become a potent symbol, a testament to the extraordinary power of human willpower, the enduring value of intellectual courage, and the unwavering belief in the boundless potential of humanity's future. In the next section, we will explore Hawking's final years, his lasting legacy, and the enduring message he left behind for the world, a message that continues to inspire and challenge us to reach for the stars. Continuing into Stephen Hawking's final years, spanning from 2010 to his passing in 2018, his life shifted its focus from the intricate equations scrawled on chalkboards to the broader mission of inspiring humanity and safeguarding its future. Though ALS had left him almost completely paralyzed, his influence, his revolutionary ideas, and his uniquely recognizable voice reached farther than ever before, impacting countless lives across the globe. During this period, Hawking dedicated a significant portion of his time and energy to addressing the pressing challenges facing humanity. He appeared at major conferences and in influential documentaries, issuing stark warnings about the escalating global risks posed by climate change, environmental destruction, the ever-present threat of nuclear conflict, and particularly the rapid advancement of artificial intelligence. He was not inherently against AI, but he urged caution and responsible development, emphasizing, AI could be the best or worst thing ever to happen to humanity. We must make sure it works for us and not against us. Hawking passionately believed that humanity must eventually transcend its terrestrial limitations and become a multi-planetary species to ensure its long-term survival against existential threats. He enthusiastically supported the ambitious Breakthrough Starshot project, an audacious initiative aiming to send swarms of tiny, laser-propelled spacecraft to the Alpha Centauri star system, our nearest stellar neighbor. It was a bold vision, the crucial first step towards interstellar exploration and the potential colonization of other worlds. Despite his fragile health, he continued to write and lecture with unwavering dedication. In 2010, he published The Grand Design, a thought-provoking book that argued that the laws of physics alone might provide a complete explanation for the universe's origin, potentially rendering the need for divine intervention obsolete. The book sparked intense debate among scientists, theologians, and philosophers alike, once again placing Hawking at the forefront of scientific philosophy and challenging deeply entrenched beliefs. In his private life, Hawking drew even closer to his family and children. After the dissolution of his second marriage, he reconnected with old friends and reveled in gatherings filled with laughter, stimulating conversation, and the warmth of human connection. Although he communicated through his iconic voice synthesizer, he remained remarkably witty, engaging, and warm, still possessing the ability to make anyone around him smile and feel at ease. He also became the subject of several acclaimed books and films, further solidifying his place in popular culture. The 2014 movie The Theory of Everything, a biographical drama, beautifully portrayed his early life, his groundbreaking scientific work, and his complex marriage to Jane Hawking. Eddie Redmayne's mesmerizing performance in the role of Stephen Hawking was lauded worldwide, earning him numerous awards and accolades. When Hawking himself viewed the film, he remarked that it felt like watching himself on screen, a testament to the film's authenticity and emotional depth. Despite his declining physical condition, Hawking remained intellectually engaged and committed to his scientific pursuits until the very end of his life. He co-authored research papers on cutting-edge topics such as quantum cosmology and the fundamental nature of space-time, some of which were published only weeks before his death. Clear and undeniable proof that his mind remained remarkably sharp, intensely curious, and relentlessly dedicated to unraveling the mysteries of the universe. On March 14th, 2018, Stephen Hawking passed away peacefully at his home in Cambridge, surrounded by the love of his family. He was 76 years old, far outliving the grim 2-year prognosis that doctors had given him in his youth, a testament to his unwavering will to live and his unyielding passion for discovery. His passing coincided with the 139th birthday of Albert Einstein, a poetic alignment that many saw as a fitting cosmic tribute to two of the greatest scientific minds in history. Hawking was honored and celebrated around the globe, his life and accomplishments inspiring millions. His ashes were interred in Westminster Abbey, a place of immense historical and cultural significance, nestled between the graves of Isaac Newton and Charles Darwin, symbolically placing him among the giants of science who have forever transformed our understanding of the world. Stephen Hawking's legacy extends far beyond his groundbreaking scientific discoveries. He taught the world that physical limitations cannot imprison the mind, that the human spirit can triumph over seemingly insurmountable challenges, and that the pursuit of knowledge is a noble and worthwhile endeavor. He demonstrated that curiosity can overcome adversity, and that the human spirit is far stronger than any illness or physical constraint. He left us with a collection of unforgettable messages that continue to resonate deeply. Look up at the stars and not down at your feet. No matter how difficult life may seem, there's always something you can do and succeed at. Intelligence is the ability to adapt to change. Today, as humanity continues to explore the mysteries of black holes, searches for habitable alien worlds, and boldly dreams of traveling to distant stars, Stephen Hawking's voice still echoes across the vastness of the cosmos, reminding us that the quest for knowledge is endless, that the universe is always waiting for those brave enough to seek it, and that the only true limits are those we place upon ourselves.